Example: evaluate surface integral if the vector f equals to x squared I minus y squared j plus z squared k. The question says that if the surface x plus y plus z equals to 1 lies in the first quadrant, which means that in xy plane, then find its surface integral. Solution: the formula of the surface integral is here, which is double integral of vector f dot product n cap ds, where ds equals to dx times dy, or magnitude of n cap dot product k. Why I put dx times dy? Because the question says that the surface, which is x plus y plus z equals to 1, lies in first octane, where first octane is the first quadrant of xyz plane. It is xy plane, and therefore I put dx dy. Perpendicular to xy is z. The unit vector of z is k, and therefore I put n dot product k here. Now let me draw the surface graphically. This is my xyz plane. These are the unit vectors I, j, k. The surface lies in xyz plane, which is x plus y plus z equals to 1. This is the surface x plus y plus z equals to 1, where the coordinates of these points are 0, 0, 1, which means that x equals to 0, y equals to 0, but z equals to 1. The coordinates of these points are 0, 1, 0, where x equals to 0, y equals to 1, and z equals to 0. The coordinates of the third point are 1, 0, 0, which means that x equals to 1, y equals to 0, and z equals to 0. The question says that the surface lies in the first octane of the plane, and the surface is here, which is x plus y plus z equals to 1. So it means that we're going to deal only with xy plane. Whatever part of the surface came in xy plane, we're going to deal with that part. We have nothing to do with the z, where this is the part of the surface which lies in xy plane. I'm going to delete the area along z-axis. So this is the required area of the surface in xy plane in the first quadrant. Therefore I have dx times dy. First I'm going to find the unit normal vector, where the unit normal vector equals to gradient per magnitude of gradient. Remember, these are the previous topics. We have already discussed unit normal vector in gradient. You must remember that. Let me first calculate the gradient, where gradient equals to I partial phi or partial x plus j partial phi or partial y plus k partial phi or partial z. Phi is actually the surface, which is x plus y plus z equals to 1. And del equals to I partial or partial x plus j partial or partial y plus k partial or partial z. Now just substitute the value of phi, which is x plus y plus z minus 1. I just shifted 1 to the left side. So it is one thing whether you write x plus y plus z minus 1 or x plus y plus z equals to 1. It is the value of phi. Now take their partial derivatives. Partial derivative of the first term with respect to x is 1. And partial derivative of the second term with respect to y is 1. Partial derivative of the third term with respect to z is also 1. So this is the final value of gradient, which is I plus j plus k. Now I'm going to find the magnitude of the same gradient. To find the magnitude of the gradient, can I write 1 in front of I, 1 in front of j, 1 in front of k? 1 plus 1 plus 1 equals to 3. But when you take its magnitude, it equals to 3 under the root. This is the final value for the magnitude of gradient. So just put I plus j plus k for the gradient and 3 under the root for its magnitude. Now calculate dot product of n cap and k. Since the surface is in xy plane, if you remember the previous lecture, we have discussed that if the body lies in xy plane, then I'm going to use dx times dy, and z is perpendicular to xy axis. The unit vector for the z is k, and therefore I put k here with the n cap. So let me put their dot product, where the unit normal vector equals to I plus j plus k over 3 under the root times k. Take their dot product. Now according to the rule, I times k equals to 0. K times j equals to 0. But k times k equals to 1. I repeat it, according to the rule, if you take the dot product of two same unit vectors, it equals to 1. But if you take the dot product of two different unit vectors, it always equals to 0. So I times k equals to 0, k times j equals to 0, but k times k equals to 1. Therefore, it equals to 0 plus 1 over 3 under the root, which equals to 1 over 3 under the root. This is the final value of the dot product of n cap and k. Now take this part, dot product of vector f and n cap. Just take their dot product, where the value of vector f is here, which is x square I minus y square j plus z square k. And the value of unit normal vector is here, which is I plus j plus k over 3 under the root. If I take the dot product between these two terms, I times I equals to 1. And here j times j equals to 1. Here k times k is also 1. So I finally left with the x squared y squared plus z squared of 3 under the root. Since the body lies in first octane, which is in xy plane, therefore can I write this equation z equals to 1 minus x minus y? Just put z equals to 1 minus x minus y, because I need everything in x and y. I have nothing to do with the z. And this is the final value of dot product vector f in n cap, which is x squared plus y squared plus 1 minus x minus y to the whole square of 3 under the root. So according to the surface integral formula, we have achieved the value of dot product of vector f in n cap, which is here, and also dot product of n cap and k, which is here. Simply substitute these values here and cancel 3 under the root with the 3. Now I need the limits for the double integral, which is x plus y equals to 1. Why there is no z? Because this surface is only in xy plane. So simply put 0 for the z. Therefore the surface is x plus y equals to 1, not x plus y plus z equals to 1. And the limits along y-axis start from 0, y equals to 0, to y equals to 1. These are the limits along y-axis from 0 to 1. Limits along x-axis start from 0 to x equals to 1 minus y. I got x from this equation, x equals to 1 minus y. So these are the limits along x-axis start from 0 to 1 minus y. Simply put these limits for the double integral here. Yeah, this is my new equation. First integrate it with respect to x to have x cubed over 3x times y squared plus 1 minus x minus y to the 3 over 3. Expand the limits here, where this term will be cancelled. It becomes 0 when you calculate. So I left with this equation 1 minus y to the 3 over 3 y squared y to the 3. 1 minus y to the 3 over 3. Now integrate it with respect to dy, which equals to 1 minus y to the 4 times minus 1 over 12. Y to the 3 over 3 y to the 4 over 4. 1 minus y to the 4 times minus 1 over 12. I hope you have no issue here. It is a simple integration and you must know the basic. So expand the limits here, where these two terms will be 0 if you calculate. And finally I have, this is the final surface integral value of that surface.